I met Keith in England about 6 years ago, I think, and I was flabbergasted. And I hope you will be as well this afternoon. Keith, can you tell me a little bit of your background?
Very, very simply, I took a physics degree and then I have taught for 36 years, mostly physics, some biology, some chemistry, but mostly physics, from the 11 years old to 19-year-old, and I retired 8 years ago. And what I do now, apart from other things, I do write a website, I write CDs, I've written some articles for people. I do actually have a life outside physics. I travel a bit with my wife. We have a lovely cat whose name is Lottie, the same as the young lady over there. I also play the cello and sing quite a lot, a number of local choirs. A bit of running, but I'm getting old, so not quite so much running now as I did.
In England, usually when Keith is performing, there's an audience of 100 to 200 people, whereas there are only 100 chairs. So people are standing and queuing up to be able to see him. There always is a group of Norwegian students, for example, who specially come to see Keith. And this is true. It's part of their education to become a teacher. So I hope you will enjoy what Keith is doing. He will not perform with a microphone, but he will involve you. And don't be scared, nothing is going to happen. Okay.
Can you see that in there? It's very difficult, you're too far away. Watch the little tube when she now pushes it down, the tube fills with oil.
Yeah.
It disappears. Thank you. Touch it with your nose.
Falling.
Up.
No.
Yeah. Thank you. Do this, but I can't do it. And it's not because I'm old, it's because I'm male. The men are heavier here compared with here. Ladies, you are heavier here compared with here. But it does something surprising. The vibrations are amplified in the tube. And talking of amplified, I've got a really nice little musical box here, and I would like someone to tell me what tune it is that it's playing. You have to listen fairly carefully. You have to ask your pupils now, it's very quiet. How do I make it louder? You just put it on the table. Okay? It's really very nice. It shows it's stationary there and the end is vibrating. There we are. Okay, do it again, the same side or different, it's up to you. Okay. Sound travels about 300 meters in 1 second. In 1/100th of a second it goes 3 meters. And in a 10,000th of a second it goes 3 centimeters, so about that. Usually, and you could certainly tell one side, people can tell which side the sound is coming. They are able to tell within a 10,000th of a second where the sound is coming from. We decided earlier on this was going to be too quick to film. It is an amazing experiment. I think this is the finest experiment of any that I do. It is so good because the hook points to the center of the circle, so it provides a push towards the middle of the circle in just the same way as the string provides a pull. Gentlemen, pull. Push down. See. Now, seriously though, keep pulling. just lean, you don't have to do anything. As you push down, keep that, it gets harder and harder And the reason is because at the beginning their force was only that way, but when you push the rope down, there is now a pull slightly upwards. And the further down, if you could go further, down more. It gets harder, you can use one hand if you want. As it gets further down, they are pulling upwards as well. Thank you. Now this, if you want the really, you know, the posh explanation. Thank you very much. Okay. This is components of a vector, isn't it? The direction of pull against the direction that she pushes down. And the further down it goes, the harder it becomes. Right? Now Lottie won't feel a thing.
No.
No. Okay, right, we'll turn it off. Instead of a pupil, Barbie doesn't mind sitting on top of the Van de Graaff. She's going to fall off. I know, maybe not. Now, all right. Now, it's beautiful because, and that is working really well, because each hair is charged the same and they all repel each other, so they stand up like that beautifully. Right? They all repel each other. The top one comes off first because it's only its own weight, and then the whole lot come apart. Yes, yes, that's fine. When they get to the top, the bubbles burst and they sink down again.
Yeah.
If you want.
Yes, oh look, you see, they are doing it. Yes, not, there we go. At the top, bubbles come off and down they go. The pressure of the air. If you press it just gently first, just gently down, the air has time to go underneath. He's going to karate chop the wood. Oh. Well, that's the first time that's happened. To the edge of the magnet. Yeah. Now I think that's really rather nice, not my idea, but look at that thing go. There's a big diagram of this one which shows the magnetic field and explains why there's a force that way. It's Fleming or left-hand rule, isn't it? It's field that way, the current which is across from the middle to the outside, and that means there's a motion along a tangent which will turn the magnet and the screw. One. Watch again. The only way to do this properly is to video it, put it on a DVD and run it slowly. 3, 2, 1. So the bottom stays where it is. Ask yourself, if we had done it with steel, would it have been quicker or slower? And it's to do with the waves going through steel compared with the waves going through plastic. This is to do with transmission of energy along a straw. You need a potato. So the idea is that you show them that if you push on the potato, it'll break the straw. I don't want to really do this, but it will break the straw, okay? Because I'd rather like to keep this straw in one piece. And I was saying this to the class, it was in the afternoon, it was hot, and I suddenly said, what you then do is you do it quickly, go, chee-cha! And this boy went, ha! And you see, it goes right through the potato. So those of you who, well, I'm going to be getting on a plane in 2 days going back to England. Don't worry about knives or scissors. Just ask yourself, you come up to the stewardess and go, yeah, in their neck, and it'll go straight through. Actually, this is quite a good straw. Usually they break after one, but it will drive straight through. The impulse is so big that it will drive through the potato because the time interval is very small, and therefore there's not enough time to break the straw. It will drive itself straight through the paper of the grooves. This is a lovely piece of physics because what you're getting is vibrations in the wood, but because it's on one side, the vibrations are doing that inside the wood just enough to make that nail turn.